Welcome back to Biology from Jay's house for the last class of the year. Woo! Holy cow, I collected homework. No, I didn't. I went over homework. No, I didn't. Now I know what you guys are thinking. Jay sure talks a lot, but what's the point? Let's go to the right, write the date for the last time. Holy cow, it's a whole new month too. Skip the line, go all the way left, right, the point. And the point is, how do killer T cells fight disease? Now, killer T cells are different than helper T cells. They're usually called cytotoxic T cells. But I like calling them killer T cells because it really reminds you what the heck they do. If you say killer T cell, people know that you're talking about a cytotoxic T cell, so it's an okay name to kind of toss around. I'm not giving you terrible information, but I'm not giving you the best stuff either. Okay, now we have to remember how all this stuff works. Now I'm going to remember we talked about two different ways of getting sick. You can get sick either through bacteria, which is living, like a robber, or virus, which is non-living. I'm going to focus on the living. I will bring back the virus just a little bit at the end because that's big right now with COVID-19. But here we go. So we are going to say that a virus has entered the body. So again, you have your skin, and the skin most of the time will keep the bacteria out. Hey, let me in. I want to get to that delicious, nutritious blood. All right, because since the bacteria is alive, it needs air. It needs, well, specifically oxygen, nutrients. It needs water. And all of those things are in our blood. So if bacteria can get into our blood, bing! Oh my gosh, it just hit an endless buffet bar. All you can eat, everything you need to stay alive, just right there. And fresh stuff gets delivered nonstop. So if bacteria can find its way into your blood, it's going to be one happy camper. And unfortunately, you decided to run with scissors, which is a terrible idea, and you now have a cut. There's a big puncture wound in the skin, the blood is coming out, and the bacteria is coming in and saying, oh my gosh, look at this. It's like New Year's and my birthday all in one. I get everything I want. Yay! Now, the bacteria is super happy. And there's a lot of bacteria in our body that is good, that we want, and we totally feed it nutrients, water, and oxygen to keep it healthy, right? And that's why people say you should have things like probiotic yogurt and stuff like that to make the good bacteria healthy. But this is bad bacteria. This is the bacteria we don't want. And now it's eating all of our stuff and gonna multiply. And left to its own devices, there'll be 2 now. Oh my gosh, look at that. There's 2 bacteria, and they'll just keep multiplying, becoming a problem, right? So, how does this work? Well, let's get our, cartoon cast characters, out here. So, we have our macrophages. And we have our helper T cells, and they kind of start the party, right? So the first thing that's going to happen, and let's get this other noise out of here, the stuff that's not really relevant right now or super important right now. First thing that's going to happen is the macrophage drives around, asks for the code. What's the code? Brains. What's the code? Brains. What's the code? Brains. What's the code? And it's going to get to bacteria, and it's going to say, what's the code? And the bacteria is going to give a wrong answer. So we'll say that the bacteria gives the word, we'll say hope. Oh, isn't that a nice word? that's a real nice sentiment, but unfortunately, it's wrong. Here, this body's code is not hope. I'm not going to tell you what the code is, but I'll tell you that you don't have it. And the macrophage goes, and he says, I've got a bacteria here, and it's using the code hope. All right, displays the code. So it eats the bacteria and displays the code hope. And we remember that the helper T cell is floating around, and the macrophage calls it over. Hey, I've got a bad guy, and he's using the code hope. He says, oh, the code hope. I think he was French before. We'll make him French. Oh, oui. You are saying that he is using the code hope? Oh, I'm going to go see what I can do about this code hope. Okay, well, be speedy about it. I will. I'll be very speedy. And off he goes. I don't know why he's French. Or really terrible French accent. It's not actual French, right? And we saw in a previous episode that he could go and talk to a B cell and deal with that. But this is a bacteria. And that means there's probably other bacteria around, right? We caught one, but there's probably others around. And antibodies, if we remember, the B cell can just make antibodies, which can affect bacteria, totally. But wouldn't it be better to just kill the bacteria? So one thing a helper T cell can do is it can talk to a killer T cell. So let's put one of these guys over here so we can remember who we're talking about. And this is a killer T cell. Now, the actual name is cytotoxic T cells. So, cytotoxic. Clearly, there's a killerness to that name, but I like to use the word killer T cell just because I think it's really clear. So, I have found that there is a bacteria and it is inside the body and it is using the code hope. Oh, hope you say. Well, I know what to do about this. Now, technically, just like B cells, technically it splits. One becomes a memory cytotoxic T cell, and he goes and he hangs out in the police station all day, just waiting for the next hope. So I'm just going to kind of put him down there, and I'm not going to talk a lot about that because we did a bunch of that in the previous video, and I'm just going to jump into I'm an effector killer T cell. I've been activated, and much like Batman, I kill things. I thought Batman didn't kill things. This one does. And he just goes and he just walks around and he asks everybody for that single code. So all he's doing is he's just marching around. Hey, is your code Hope? No, mine's Prince. Okay, you're cool. Hey, is your code Hope? No, mine's also Prince. Okay, you're cool. Hey, is your code Hope? Yeah. Yeah. My code's Hope. Got bad news for you. Gah, 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 gah. And it kills it. It literally tears it apart. It releases perforin. That's an actual chemical, perforin. And perforin perforates it, like pokes it full of holes, and like tears open. Imagine like ripping his skin open and letting his innards come out. It's that terrible. That's what he does. Take some perforin. I'm going to perforate you. And this guy literally just bleeds out. And he is dead. Hey, is your code Hope? Yeah, my code's Hope. Got bad news for you. I'm a killer T cell looking for the code Hope, and I kill. Stop perforating me. My innards are spilling out. That's what I do. I'm a killer T cell. He's dead. Hey, is your code Hope? No, my code is Rumpelstiltskin. Oh, well, that's not Prince, so you're probably going to die soon, but not from me. I only kill Hope bacteria. And off he goes. And that's it. That's the whole idea, is a helper T cell brings the code to a killer T cell. Killer T cell once again splits, bloop, one becoming a memory killer T cell, or memory cytotoxic T cell, and the other one goes on the rampage. Yeah, hey, if your code is hope, your days are numbered. And that's the whole thing. So there's really two responses, right? One is we can go to B cells, right, which release antibodies, which are non-living chemicals that disable viruses, also can disable bacteria, and flag them for the macrophage, right? Or we can take the law into our own hands, be judge, jury, and executioner all in one, and just kill, kill, kill. And that's what the killer T cell does, right? So you have a B cell, which was talked about in previous videos. You have a killer T cell, which is talked about in this video. And I want to talk about viruses. The same thing can happen. It can come up and the virus's code can be hope, and it can kind of crack the shell of the virus. So killer T cells can also help with viruses, but I think it's best to think of B cells. I think the easiest thing is B cells kill viruses with non-living antibodies, and killer T cells kill bacteria by perforating them. And though there's overlap, and B cells can attack bacteria and killer T cells can hurt viruses, I think it's best that, for an introductory video or introductory series of videos, if you think of B cells destroying viruses and killer T cells destroying bacteria, I think that'll help kind of keep things clear in your head. Now, what does all this have to do with our new friend, COVID-19? COVID-19's not a friend of mine. Well, it's not a friend of anyone's, actually. We're all pretty bummed that and it's now lurking around us. I'm going to add B cells to our cast of characters. Oops. Except I'm going to move it over a little bit. And this is where we talk about the difference between there being immunity to something specific and something non-specific. So non-specific immunity is things like your skin. You can have two viruses, right? One can be Kenny G, one can be Rumpelstiltskin, and that doesn't matter. They both can't get in through the skin, right? You can have two bacteria, right? Where one bacteria is hope and the other is Ferrari. It's a great code, right? And again, the skin doesn't let them in. So a skin is non-specific because it doesn't matter what you are or what your code is, you're not getting it. So that's kind of non-specific. Now we're going to talk about just COVID-19. So let's say that there was a cut, or more likely, you touched the doorknob and then you licked your hands because you touched the doorknob, but there was some Cheeto dust on it. So you touch the doorknob, you go, oh, Cheeto dust. Cheeto dust, totally worth it. And now you have COVID-19 inside your body. Don't do that. That's a terrible idea. Just wash the Cheeto dust off. Go buy fresh Cheetos. Don't eat the ones off the doorknob. So the question is, why is everyone getting sick? And I think it's worth kind of seeing this once. And so this comes in, and we're just going to say that its code is COVID. There's a nice, easy code. So again, macrophages are driving around. They're asking everybody, what's the code, mate? It says, Prince, you're cool. What's the code, mate? Prince, you're cool. What's the code, mate? COVID? Bad guy. And the macrophage eats it. Woohoo! if I could do that correctly. Macrophage eats it, and it says, okay, I have got a virus, and its code is COVID. All right? And we've seen this before. What happens? The helper T cell gets called. Oh, you said that you have a virus, and the code is COVID. Let me go find out. And he goes back to the police station. And the police station has B cells. It's full of these B cells. It's full of these cytotoxic T cells. And it says, excuse me, everybody, all the B cells, all the cytotoxic T cells, we have a new virus. It is amongst us, and the code is COVID. So whichever one of you, and there's a bunch of them. Sorry, I should make that more clear. There's a bunch of them. Whichever one of you knows the COVID, you go. We don't have any B cells that know COVID. We also don't have any T cells that know COVID. You're saying that no one in this entire police department knows anything about the COVID virus? Nope, never seen it before. Nope, no history whatsoever. This body has never interacted with COVID ever before. Oh, this is a bit of a problem, eh? And meanwhile, what's happening? More COVID is getting in because you licked all that Cheeto dust. So even though one was captured by a macrophage, and maybe even a second one was captured by a macrophage, right? And once again, helper T cell, comes in, says, oh, you're COVID also. And he shows up saying, hey, does anybody know COVID? Yeah, I just asked that. Oh, well, that's wonderful. Which one of us is the COVID? And everybody says, none of us do COVID. He goes, oh, that is a bummer. And while that's happening, this virus is infecting the cell. Loop. And it makes the cell into what? An angry photocopier. Shooting out. Oops, that's upside down. Just shooting out one after another, more and more and more viruses, more and more of these COVID viruses. And it'll make a bunch of them. And so for us to fight this disease, we actually need macrophages to eat it, and then we need our bodies, we need our B cells to figure it out. We need to find a way to kill a COVID, and then we have to bring it back to the police station, and then we have to make copies of it so one of it stays in memory, so the next time someone comes in and says, hey, does anybody know COVID? He's like, yeah, I remember. We got it in late March of 2020. I've got this. But we don't have that right now. That's the problem. This is what they call a novel illness. It enters our body, we find out the code, and we have nothing in our police station. We have nothing in our lymph nodes. We have no way to make antibodies against it. We have no way to fight it directly. That's just it. And meanwhile, while we're trying to figure that out in our lymph nodes and we're trying to figure out how to deal with it, the copier is making more. And then this guy infects this cell. He becomes a copier. He shoots out more. And we just end up with tons and tons and tons of these COVID viruses in our bodies. And so that's what's going on. That's why we have to be really, really careful about this, because most of the time what happens is when all this happens, when the macrophages eat the COVID and the helper T cells alert the police station and the B cells and the T cell, the killer T cells all work together, usually what ends up happening is you end up getting a fever with that, right? All this work in the police station will give you a fever and you'll develop a cough and you'll have all these symptoms, right? And then we know you're sick and we kind of ask you to kind of stay away from the population, and your body will fix it for most people. It's going to be terrible, but most people will fix it. Most people, their B cells and T cells will totally fix it. And as long as it gets into your body, you make tons of it, but you kill it before it leaves your body, and goes out and infects somebody else, as long as you kill it inside your body, then we're golden. But if there's a lot of people out there who, while all this work is happening, while they're fighting COVID, they don't get a fever. While they're fighting COVID, while all this work is happening, they don't get a fever. They don't get sick. They have like a slight cough. It feels like they just have allergies or something like that. And so they do go outside, and then they do release the COVID into the air. And then people who can't fight it, people who by the time all this work is done, they're already so sick they're not getting enough air into their bodies, right? And their body shuts down, right? And that's going to be people who are elderly or people who already have like asthma problems, like respiratory problems, right? So the reason that we have to stay away from each other is because while your body figures this out, you may be aware of it, but you may not be. And once your body figures it out, then it will release the B cells or release the killer T cells. It'll deal with it. It'll kill it all. And you won't have released any COVID out to infect somebody else. So we just have to wait long enough that happens, that that this stops being novel, and when the helper T cell shows up with the COVID, your body knows how to deal with it and you're good. All right? So that's the main thing. That's why we're in shelter in place, because if you get infected, most of you will figure it out. Your helper T cells will bring it to your lymph nodes. Your cytotoxic T cells and your B cells will just figure it all out. You ultimately will kill the virus as I'm breaking it apart and dealing with it, and you'll stop these copiers, right? Because another thing killer T cells do is they can come to these cells that have been infected. Hey, what's the code? And now this guy doesn't know the code. He's a copier. He actually doesn't even really respond. And he'll kill it. Gah, gah, gah. And he'll do his perforant thing. Stab, 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 stab. And then this copier will die, hopefully before releasing many, if any, viruses. Right? Same thing here. Hey, you, evil copier, what's the code? No response because he's busy making new viruses. Stab, 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 stab. And he just dies, hopefully before releasing viruses into the body. So killer T cells can really help with that, but this all takes time. So please wash your hands, keep yourself safe, make it so that you don't get COVID. And if you do, if you just stay away, then the COVID in your body won't get out, won't infect people who can't fight it, who by the time they figure all this out, it's too late. And we'll be okay, right? So that's my plea. Wash your hands, do your shelter in place, and good luck out there. Oh, wait, I didn't answer the point. I got to do that thing. That's the thing that I need to do. So let's get all these crazy things out of here, out of the way. How do killer T cells fight disease? Killer T cells, also known as cytotoxic T cells, pop bacteria and infected cells using perforin. Hope I have that spelled right. I think that's right. I don't remember if that's right. Let me just say using chemicals. That way I know that I'm not giving you bad information. So that's what the killer T cells do. They pop bacteria. They literally pop, 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 pop. They release this stuff called perforin, and the bacteria just bleeds out. Okay, that's all I got for you. It's been a wonderful year in biology. Good luck, and I'll see you next year.